sometimes we are given the slope, sometimes we don't know what the slope is, sometimes we can look if we have the equation. But remember that the slope of a line is given by m equals y2 minus y1, x2 minus x1. Notice down here though, there are two versions of that are considered to be correct. There are two versions that we can use. That is y2 minus y1 if that's what you want to do, or you can do y1 minus y2, and that's fine. Just keep in mind, if in fact you do reverse those, make sure that you reverse it in the other one as well. If you don't reverse it in the second one, then you're going to end up with opposite signs than what you're supposed to have. So please make sure that anytime if you decide that you pick the one point versus the other, make sure that you do in fact select y1 first and you select x1 first. It doesn't really matter because you really define what point 1 and point 2 are in any of those anyway. Alright, so the incorrect way to do that is exactly what we just mentioned. y2 minus y1 over x1 minus x2. You've reversed two of those. And when you reverse two, notice how these are not lined up like they're supposed to. The slope does become other than what it's supposed to. So here we look at this slope, y2 minus y1. That's really just the change in y divided by the change in x. That is, as we learned a long time ago, the rise over the run. Now, those of you in chemistry that will be taking chemistry, your chemistry teacher will appreciate this as well. An easy way to say, and you'll see this in calculus next year maybe, an easy way to say change is with a triangle. That is the Greek letter, lowercase Greek letter delta. So we can say delta y, that is change in y, over delta x, the change in x. So through symbols, we can say the exact same thing as we have with words such as rise over run. All right? So here we go. Let us calculate the slope of the line passing through the following points. At this time, if you would like to pause, this will be a very good opportunity for you to do so. Slope is one of those things that not too bad to do, and you guys could probably figure this out pretty easily. So I'm going to give you a chance to pause. If not, we're going to go ahead and just jump right on into it. Alright, so we are looking at -2, 0, and 3, -1. What does the slope of that line look like? Well, if I want to use x1, y1, x2, y2, again, they don't tell me which one's which, so I literally just go up here and say, okay, this one's x1 just because I want it to be, and this one's y1, and this is x2, and this is y2. So I'm going to calculate that one. Well, I can say 1 minus 0 over, so 1 is y2 minus y1, which is 0, and then now don't forget to not reverse them. You got to pick them in the same order. 3 minus a -2. That's also important. It's minus a -2. You cannot change that order at this point. It's minus a -2. Make sure that you pick it in that order because minus a negative is something else. So 1 minus 0 is 1. 3 minus a -2. We might have learned to do this. So let's go ahead and just turn that into a plus. It's really 3 plus 2. Minus a negative is addition, so 3 plus 2 is 5. So the slope of part A is 1/5. What does that look like? Something like that. You can plot and then just, do rise over run yourself, or you can simply go through and calculate mathematically. Whichever way you choose, it's okay. It does not matter. You have that option. All right. So now the next one. The point for B is -1, 2, and 2, 2. So let's plot that one. So for part B, over here we have -1, 2. And we can call that again same way. So x1 x2, y1, y2, and so on. So then I'm going to pick from this one first. So 2 minus, and go ahead and label that x1, y1. You don't have to do that, but it always helps. x2, y2, especially now because 2 and 2 are the same for y2 and y1. And then when I go to the next part, I need to make sure I do x2 first, which is 2, and then minus a negative 1. This one is not really going to make a difference. Because what's 2 minus 2? 0. What is 2 minus negative 1? 2 plus 1, 3. And what's 0 divided by 3? 0. So what does that one look like? As we expected, a horizontal line. There is a dead giveaway for this one. When we look at this one, the y value never changed. The y value was always stuck at 2. And because it was always stuck at 2, that almost tells us, hey, that's got to be a y equals equation. It's stuck at 2. It's not going anywhere. So y equals 2 is the answer to this one. Now, for part 3, we got the part C. We have the points 0, 4, and 1, negative 1. Now, we can label again. I'm just going to use the labels that are already up there. Just carry those down. So when I go to calculate this, I have y2 is negative 1 minus y1 is 4 over x2 is 1 minus x1, which is 0. So negative 1 minus 4. I owe somebody $1, owe somebody $4. I'm going to be owing some more money. And a grand total of 5. 1 minus 0 is 1. Negative 5 over 1, well, that's just equal to a pretty steep negative slope of negative 5. All right, last one. If you notice, if you caught on to what happened with B, you notice this one, there's something going on here trying to tell you what's going on with this equation. And if you notice, this has x1 and y and x2 the same exact value. There's something to that. Let's calculate the slope mathematically or algebraically first. y2, we bring that down, that's 1 minus y1 is 4 over x2 is 3, and then x1 is also 3. Well, that didn't change, so x does not change. 1 minus 4 is negative 3. 3 minus 3 is 0. And the question that I had to ask is, what is negative 3 divided by 0? A lot of you may think, oh, that's 0. I'm taking negative 3, I'm dividing by 0, that's 0, right? Well, it's all fun and games until somebody divides by 0. You can ask Siri even, what is 0 divided by 0? And Siri will give you a long explanation about Cookie Monster and something about cookies and friends. I can quote it completely, but I won't spoil it for you. I'll let you go ahead and try that if you have an iPhone app. But basically, division by 0 is undefined. You cannot have something and divide it to no one. It just doesn't make sense. It is an undefined slope. It is indicative of a vertical line. The slope is undefined. It stays at 3. X never changed. All right, any questions on that so far? So here we go. The other useful portion of this here is the point slope form. The point slope form is a little different. As you notice, there's no y-intercept here this time. Instead, what we do have is y minus y1, m parentheses x minus x1. We notice a couple of things here that are familiar to us. First of all, there's our guy again. There's m, our slope. This time, though, it does not have a y-intercept. However, it does have x and y without labels, and it has y1 and x1 with, the subscripts. That is a point. The given point to you, the slope is m, and it passes through some point with coordinates x1 and y1. Now the ones that don't have numbers to them, those are just your regular x and y variables. But I want you to take a look at what happens here when I take the point slope form and then I solve for m. You're actually going to see something very familiar about this. So if I'm trying to get m by itself, I'm trying to get this guy here to stay. I'm going to divide both sides by anything that's not m, and I can use a whole parentheses that way. When I do that, divide both sides by whatever is being multiplied to m, it's going to leave me with m on this side, and it's going to leave me with y minus y1 over x minus x1 on the other side. Does that look familiar to you? Because I sure hope it does. That is, in fact, the same exact thing we were just talking about when we were talking about slope. All right? So, slope is y minus the change in y over the change in x. But in a different form, a more useful to us, if we have a slope and we have a point, we can use this form right here. Y minus y1 equals m parentheses x minus x1. That is not one that you have to memorize, but it's probably pretty good idea to commit that one and you store that in your bank. All right? So then here's your chance to use those, that new knowledge on those equations. And I want you to find the slope-intercept form. What is the slope-intercept form? You're going to find the y equals mx plus b form of an equation that's been given a slope and a line, or a slope and a point that it goes through on that line. Well, you can't use y equals mx plus b unless you know for a fact that you have a y-intercept. In this case, you have to start off with y minus y1 equals m and then x minus x1. You have to start here. Then you can plug in those numbers and then solve for y when you're done. So if you would like to try again on your own, this is a time to pause. Otherwise, here's part A. So I'm going to plug in those values. I only have 1 point. There's no argument. So this is x1, this is y1, and label it so you know that y is still y. y1, however, is negative 7. So minus a negative 7 equals, and then I have my slope, which they gave me as a 2, and sometimes you actually might have to calculate the slope yourself. And then parentheses, x minus, and then x1 is right here, it's 3. And then at this point, I'm just going to do a little bit of algebra and solve this. So y, clean it up, plus 7 equals 2x minus 6. Last step is I'm going to subtract 7. Subtract 7, so y equals 2x minus 13. And hopefully you try that on your own, and that's exactly what you got. Alright, so that was part A. For part B, I'll make some room real quick. Oh, don't want to move that guy. You want to move this guy here. Let me see. There it is. Alright, so for part B, I'm just going to move that over here. I'm going to use the same equation. It gives me a slope. It gives me y, and then y1 is negative 1. Or just 1, so y minus 1, excuse me. And then the slope is negative 2 over 3. And then x minus a positive 1. Alright, now you notice something slightly different here that some of you may or may not like, I don't know. But when I'm looking here, you have to think, okay, I got a fraction I'm going to have to deal with. Is there a way that I can make my life easier at this point? And there is. I'm going to start here on this side of the equation. So I'm actually going to go ahead and say negative 2 over 3 times x. And then negative times a negative plus 2/3 times 1, 2/3. The reason why I did that side first is because I'm seeing a lot of fractions here. I had nothing that I had to do on this side. However, when I go to write this one, I'm not going to write negative 1. Instead, I'm going to write negative 3 over 3. Why did I do that? 3 divided by 3, isn't that 1? Putting something over 3 is going to play nice with a fraction that already exists. So now when I go to do my next step, I save myself a huge headache by saying I can add 3 over 3, and now I have y equals negative 2/3 x. 2 over 3 plus 3 over 3, add the numerators, 5 over 3. And there's my final point-slope form, or excuse me, slope-intercept form of the equation that I had to use point-slope to start off writing. Then I'm going to slide the page down a little bit so I can go over here and do the last one, changing colors again. So part C, if you're keen and you have noticed the slope here is 0, you can take a shortcut. However, let's pretend we did not notice that and we said y minus 1 equals 0, parentheses, x minus 1. What is 0 times anything going to do? Wipe this whole thing out. So all of this times 0 is just 0. So that goes away. So really I have y minus 1 equals 0, or y is equal to 1. And what I mentioned earlier, if you notice, the slope of 0 is a horizontal line. Horizontal line goes through the y value and stays there. So I could have just looked right here, right in the beginning, at my y value with a slope of 0 and say, well, my equation is just y equals 1, because it's a horizontal line.